In this video, we're going to focus on solving trigonometric equations. So solving trigonometric equations, this is just the same as solving algebraic functions, all right? Or our goal is to find the value of whatever variable is involved that will satisfy the equation, or in other words, that will make the equation true. In this case, we will be dealing with equations involving trigonometric functions, like this equation here. So what we need to do is to find the argument of sine function, or the value of this angle here, angle theta, that will make this equation true, or that will satisfy this equation. All right. So in order to solve trigonometric equations, we have some guidelines that we can follow. First, if the equation only involves a single trigonometric function of a single angle, just isolate the function and then solve for the angle. Okay, we'll see later on how this guideline is applied. All right. Next, if the equation involves terms that can be isolated on one side of the equation and can be factored, basically if the equation involves expressions that are factorable, then we apply factoring, just like what we usually do with algebraic equations. Okay, if the expressions involved are factorable, we apply factoring, and then we apply the zero factor property. All right. Next, if the equation involves two or more trigonometric functions, this is the time where we apply identities. Okay, so two or more trigonometric functions of a single angle expressed in terms of a single trigonometric function, again by using identities. All right, and then just follow the guidelines mentioned above. Now, if the equation involves more than one angle, so let's say we have theta, we have 2 theta, 3 theta for a single equation, then again we apply identities. All right, so let's look at some examples. First, let's try the equation that we had earlier, 2 sine theta plus square root of 3 equals 0. All right, notice we have a restriction here for angle theta. This is because of the cyclic nature of trigonometric functions. If we do not restrict the value of angle theta, then we can have an infinite number of angle theta that will satisfy the equation. Okay, and so we limit the angle of theta from 0 to 2 pi only, or that's 0 to 360 degrees, excluding 2 pi or 360 degrees. Okay, so we can do that. We can also include 360 degrees. It depends on the problem. All right, so let's start. Now, what we have here is a single trigo function, just one trigo function, sine function, and then also one angle. All right, so we can just isolate the trigo function, also isolate all the constants on one side of the equation, and then solve for theta. All right, so transpose square root of 3 to the other side, we get negative square root of 3, and then divide both sides by 2. This gives us sine theta equals negative square root of 3 over 2. Okay, and then from here we can now determine the value of angle theta. Okay, also before we continue, since our goal is to find angle theta, we can isolate angle theta by eliminating the trigo function on the left-hand side of the equation. In order to do that, we have to apply inverse trigonometric functions. In this case, inverse of the sine function, or arc sine. Okay, so apply arc sine on both sides of the equation. This gives us theta equals. This is to explicitly isolate angle theta, all right, applying inverse trigo function. So again, theta equals arc sine of this value here, negative square root of 3 over 2. These two equations essentially mean the same thing, and that's what angle whose sine function is equal to negative square root of 3 over 2. In other words, if you take the sine function of that angle, of that particular angle that we don't know yet, the result is negative square root of 3 over 2. All right. And in order to do that, we can use, or we can refer to the unit circle. All right. Remember, our goal is to find angle theta whose sine function is equal to negative square root of 3 over 2. So we are looking for ordered pairs where the y component is negative square root of 3 over 2. Y component because again, uh, the sine function corresponds to the y component of the ordered pair in the unit circle. All right. So let's look for uh, y components that are negative square root of 3 over 2. All right. And so um, negative y components can be found in the third quadrant and the fourth quadrant, right? So we have here this angle, y component is negative square root of 3 over 2. So 4 pi over 3. And then in the fourth quadrant, we have this angle, 5 pi over 3. Again, its y component is negative square root of 3 over 2. Therefore, those are the values of angle theta that will satisfy this equation for this restriction from 0 to 2 pi, including 0, excluding 2 pi. All right. Again, we have 4 pi over 3 and 5 pi over 3. To check, we can use our calculators, plug in these values to the equation, and make sure that the mode of the calculator is in radians because the angles involved here are in radians. All right. Next, we have here 2 sine squared theta minus 3 sine theta plus 1 equals 0. So let's find angle theta that will satisfy this equation, again, taking into consideration the restriction that we have here. Okay. Now, what are the trigo functions involved here? We only have one, and that's sine function. All right. We also have only one angle, and that's angle theta. Therefore, to solve this equation or this trigonometric equation, we can treat it as an algebraic equation. All right. And to do that, we can replace sine theta by another variable, say x. All right. So let x be sine theta. This gives us 2x squared minus 3x plus 1 equals 0. All right. As you can see, we have a quadratic equation. To solve quadratic equations, recall that we can apply factoring, we can apply completing the square, quadratic formula, so on and so forth. All right, for this one, we can try to factor, and this is factorable. The factors are 2x minus 1 and x minus 1, right, equals 0. And so we can rewrite this trigo equation given here as 2 sine theta minus 1 times sine theta minus 1 equals 0. And then we apply the zero factor property where we equate the factors to 0. Okay. And then we isolate sine theta. This gives us sine theta equals 1 half and sine theta equals 1. Again, our goal is to find theta. In this case, we have two solutions. All right. For the first one, what angle theta whose sine function is equal to 1 half. And then for the second one, what angle theta whose sine function is equal to 1. Again, let's refer to the unit circle. Let's look for y components that are equal to 1 half and equal to 1. Okay, so we have here 30 degrees or pi over 6. So the y component is 1 half. All right, and then we have here 90 degrees or pi over 2. Its y component is 1. we also have here 5 pi over 6. Okay, so we only look for we only look at the upper half of the unit circle because the values are positive. Okay, and so these are the angles where its sine or whose sine function is equal to 1/2 and sine function equal to 1. We have pi over 6, pi over 2, and 5 pi over 6. All right. So again, pi over 6, pi over 2, and 5 pi over 6. Next problem, we have here 3 cosine theta plus 3 equals 2 sine squared theta for theta greater than equal to 0 but less than 2 pi. Okay. Now we have two trigo functions here, cosine theta and sine theta, and only one angle, which is angle theta. The first thing we need to do here is to transform or convert this equation into an equation involving only one trigo function. It's either in terms of cosine only or sine only. All right, as long as it only involves one trigo function. All right. So it's either we convert cosine to sine using identities or convert sine to cosine again using identities. In this case, we can apply the Pythagorean identity for sine squared theta so that we can convert it to cosine. Alright, and its equivalent is 1 minus cosine squared theta. Again, this is from the Pythagorean identity. Okay, so we just simplify, rearrange so that we can uh, isolate all the terms in one side of the equation, on one side of the equation. Okay, so we can clearly see here that this takes the form of a quadratic equation, right? And if we factor, this gives us 2 cosine theta plus 1 times cosine theta plus 1 equals 0. Apply zero factor property, equate the factors to 0. So we have 2 cosine theta plus 1 equals 0, and then cosine theta plus 1 equals 0. Next, we isolate cosine theta. This gives us cosine theta equals negative 1/2 and cosine theta equals negative 1. And then let's refer to the unit circle. Let's look for angles whose cosine value is negative 1/2 and negative 1. And then recall that the value of the cosine function of an angle corresponds to the x component of the ordered pair. Okay, so let's look for x components equal to negative 1/2 and negative 1. These are negative values, all right? So let's look at the left-hand side of the y-axis. Okay, negative 1/2, x components that are negative 1/2. We have here uh, the angle 2 pi over 3, x components negative 1/2. 180 degrees or pi, its x component is negative 1. And then lastly, we have 4 pi over 3. Okay, its x component is negative 1/2. So again, we have 2 pi over 3, pi, and 4 pi over 3. Next, last problem. The given is sine 2 theta plus 2 cosine theta equals 0, where theta is greater than equal to 0 but less than 2 pi. Okay, so what we have here are two trigo functions, sine and cosine. We also have two different angles, 2 theta and theta. So the first thing we need to do is to transform this equation so that we can only see one trigo function and only one angle. Okay, so for this equation, we can apply an identity for sine 2 theta, the double angle identity, and its equivalent is 2 sine theta cosine theta, right? So we have here 2 sine theta cosine theta plus 2 cosine theta equals 0. Factor out the common factor, and this gives us 2 cosine theta sine 2 theta plus 1 equals 0. And then 0 factor property, equate the factors to 0, and then isolating the trigo functions, this gives us cosine theta equals 0, and then sine theta equals -1. For the first solution, we need an angle whose cosine function is 0. For the second solution, we need an angle whose sine function is -1. Alright, so let's look at the unit circle. First, let's find this angle here, whose cosine function is 0. So we are looking for an x component that is 0. Okay? And it's pi over 2, right? The x component is 0. And also 3 pi over 2. Okay? The x component is also 0. Alright? Now let's look for the angles whose sine function is -1. So negative y components are situated below the x-axis. Okay? And so -1, this is a quadrantal angle here. Okay? That's 3 pi over 2. Therefore, the value of the angle theta, or the values of the angle theta that will satisfy the equation are pi over 2 and 3 pi over 2. Okay?